Alright, welcome everybody to week 4, day 2 of ISFDA game development. I'm going to show off the little game that my daughter and I made along with one of my coworkers at the school and one of my students who did a little bit of the art. And I'll go ahead and play it for you and just kind of see what's going on. And keeps leaving the channel. Okay, so play. It's got some techno music coming. Got animations. You notice when I run forward, strafe uses different animations. And I lost the game. Try it again. So if I kill one of these guys, they just kind of a cool particle effect where they disintegrate. I don't know if that comes through in the streaming. My daughter built this whole thing here. Attenuation. Yeah, probably could. It's not really OSHA compliant. So you can hear the attenuation as we get away from it. And there we go. So your goal is to simply delete, from existence all of the laser zombies before they kill you. The laser zombies are AI controlled. They will pathfind around to navigate to get to you. You can learn how to make mods like these. Yeah, I'm gonna show you today. That's our topic for today, I guess. We can pick up the discussion of auto materials for landscapes on Tuesday of next week. So let's do this. So, oh, you don't even know blueprints yet. Yeah, we're gonna have to go over blueprints first. Yeah. All right. Let's go and minimize that. Couple bit of prerequisites you need to get under your belt first. Okay, so I'm gonna launch fall 2021. Okay, so we got here the fall 2021 level we've been working on. When I click, nothing happens. I don't have any ability to attack. I can't jump either. All I can do is walk around. Okay, so let's talk about how to do coding, and we'll continue our discussion of landscape materials another day. So, I've made a directory called build that I put all my stuff in. Just inside of here, I'm going to right click and choose new blueprint class. So blueprint classes are like where you know, there's code. It's like a visual coding system. And we're going to make like a, I don't know, like an area that if you walk over it, it you know, yells at you or something out. Okay, so we're going to make an actor. An actor is just anything that can go into the world, even if it doesn't have any graphics associated with it. Anything that goes into the world is called an actor. So we're going to make an actor here. We're going to call this one Yeller, Old Yeller, I don't know, Yeller. And then I'm going to open it up. So what I did was, again, I right-clicked on the asset browser, chose new blueprint class, made a new, oops, I just made a new level, that's all I want. New blueprint class, pick that actor. Okay. So then double click on it to open it up. Open full blueprint editor, there we go. And so this is what a basic empty blueprint looks like. I had to click on open full blueprint editor to do that. So this this white sphere here isn't going to draw. It's just an art reference to show us where the origin of the world coordinate system is. So we're going to add in a couple coordinates, a couple things. Let's maybe bring in the maybe do a snowman in here. That'd be fun. So we'll do this more properly than the sort of ad hoc way we did it before, where before when we made the snowman, we were just kind of dragging spheres around inside of the world editor, which isn't exactly the best way of doing it. So let's do it here. So let's go ahead and hit add component, and we're going to choose a sphere like this. And for the material, I'm going to pick dirty material. Let's see, snow. That's pretty intense. It's got a displacement map which deforms the snow. Let's see, what's a good snow? We'll just leave it as white for now. And I'm just gonna save this, and I'm just gonna drag it out into the world just so I can see. Okay, that's kind of what it's gonna look like right here. All right. And because the root is right there, that's the spot that it uses to drop to the ground. And so you can see part of the snowball is below the ground then. So I need to lift this up until it's sort of like out of the ground. It just kind of touches like that. And then every time you hit compile and save, then you can take a look at your thing as you're building it. Sort of like a comparison process, right? This one's material is Frosty material. Okay, so we'll just copy that. We'll just call this one Frosty material. Compile, save, and there we go. So we got our first ball of Frosty here. Then we're going to click on the add component again, and you got it. We're going to build another sphere, and this one will be sort of on top of the other one. This, and if you're like, wait, I thought this was the code part. Yeah, it is. Blueprints are the code part, but they sort of tie very nicely with the graphics here. Control. Yeah, I'll just add another one. That's fine. And then this one is going to come up here. Okay. And so it's the same process, except rather than building Frosty out in the world one at a time, what I'm going to do is, because all these are different objects, which is just kind of weird and awkward. And I could group them, but it's better to do it inside of a blueprint like this, because now, watch what happens if I click on this. All three of them select. You see that? So the whole thing comes together. It's considered one object. And it's really the way that the world is meant to be. This is the way the game should be played. And so every time you open up your blueprint, it might take you to the event graph, which is where you're going to do your coding. But we're going to click over here on viewport and keep building Frosty here. Now, which way is forward? Which way is forward by default? Well, let's add a new cone. You can see that it's looking down the red axis here. And here it's looking down the red axis. You see there's a little guide down here. So that's no surprise, that's the direction it's looking. Alright. Let's rotate this around. This is all stuff you guys should know already. And for the nose, we'll just use the nose material that we made before. Might be a little bit too high. Let's drop it down a little bit. And then you can name each of the different components you add to it. So what we're doing is we're building an object, okay? And we're going to make it intelligent in a second. So combine the code with materials and other things, yeah. Okay, so let's add another sphere, and this one will be the first eye. So we'll move this up and shrink it down. Control W duplicates. And actually, before we duplicate it, let's give it a material. Control W. And move it over here. And there we go. So we got your first homework assignment recreated in just a few minutes. And you can see over here, it's more or less the same thing. Okay, it's like American Gothic, except snowman style. Okay, so let's do something with this. So let's come over here to the event graph, and let's just do begin play. So begin play is something that runs once. It runs when the object kind of gets put into the world. When it's made, it'll run one time. And so let me show you the first code, the first program you're going to write. And in computer science, the first program you always write is called Hello World. So I want you to drag off of this white node here, like that. So this is how you do programming in Blueprints. These white pins indicate the flow of execution. So when the world begins, essentially, this event is going to get called, and then the first thing it does is it's going to print to the screen the words hello world, like that. And then if I want to do something else after that, I could drag off from here and I could have it play a sound or do a particle effect or something. Don't need to worry about that right now. Let's just start with hello world. So when the map loads, essentially, it's going to print hello world. See right there, hello world, and then 5 seconds later it vanishes. Okay. There's another one over here called event tick. Event tick runs every frame, right? So I am in event tick. Print string is just a great thing to use to just kind of see where you are, what's going on. There's debugging tools as well, but it's just really easy to watch. When I hit play, I'm in event tick, I'm in event tick, I'm in event tick. So it's running every frame. So if I'm getting 90 frames a second, this is going to run 90 frames a second. For that reason, putting things into event tick is not always the best option. It can need a lot of your CPU time and stuff like that. So if you're doing things like AI, or my AI code over here, I can show to you. So I built this thing here. So this is the bad guys, and I give them a glass body, and then I apply a particle effect to their body to kind of outline it. And then when the particle effect fades, it's like they've gone stealthy, and then yeah, it's a pretty cool effect. So if I turn the body off, then all you can see are the particles. And anyhow, so coming over here to the event graph, there's a lot of things going on to make my zombies do their zombie business. But basically, you can see here on event tick, I got a lot of stuff hooked onto event tick, but it actually doesn't run every frame because I've got a variable that holds when the last time I actually thought. I've got a think delay of 1 second. I could lower that to like 5 seconds. These things would only think once every 5 seconds or so. And so basically, what this code over here is doing is saying think once every second. So rather than every frame, this code here is limiting it to just every second, which is pretty normal. All right, so let's come back over to here, and so you can see that let's not do that. That's going to spam us with event ticks and things like that. So what can we do? Okay. Well, we could have the snowman say hi to us if we're in front of it. We can have it say hi to us if we are near it. There's a lot of different ways we can do this. There's always different ways of doing stuff in Unreal Engine. And a lot of the times I show the worst, maybe. I don't know. There's always different ways, and I always kind of like, should I do it this way or that way? So the first thing I'm going to show you is an overlap. So I'm going to add a component called a collision, a sphere collision. And this is going to make a invisible shell like this that I will center on the snowman. Okay, so if we come back to the world, you can see that it's drawing it, but when we play, it's not drawn in the world. It's just a debugging things, you can kind of see where the collision area is. And you can walk through it, right? Like this is transparent to players and stuff like that. You can't walk through the snowman. Snowman's solid, but we can go through that collision zone. So maybe collision isn't the best name for it. What it will do though is it will generate what are called overlap events. Overlap events, overlap all dynamic. All right. Okay. So what we can do is say when something enters this invisible sphere, do something. Okay. And this technique is used all throughout video games, right? You walk up to a door, you don't need to hit a button, you don't need to turn the doorknob, you just walk up to it, and then the door opens, right? You guys know what I'm talking about in a video game? Like, some video games simulate doors accurately, but most of the time you just walk up to them and the door opens. Right? So, yeah, sliding doors at a grocery store, right? And so you'd simulate that by having either a sphere collision, or you could use maybe a box collision. Depends what shape you want, really. That. So you can have either a spherical one or a square one. Probably for like a sliding door at a grocery store, I'd make it square so it matches the shape of the door and just have it come out a little bit. And then when you walk over it, it's going to do something. So let's delete this box collision. Okay, so where was I? Undo, 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 redo, undo. Okay. So I don't know why this thing turned red. Weird. Okay, that's fine. Okay, so let's show you guys some programming. So I've built my snowman over here, and I've attached a sphere collision to it. And so what I want to do is say when something enters the sphere, do something. This is called event-driven programming. So rather than every tick having the snowman go, is the player near, 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 which might work for one snowman. If you have 10,000 of them, it is definitely not a good, programming style. Okay, instead, just allow the event system to work like it should. Okay. This. And so basically, when somebody begins overlapping us, we can't overlap the solid bits, right? You can hit them, you can rub your face into them. That's a different event. There's an event on hit. If somebody walks into you, shoot up, which might actually be fun. Have the snowman fall apart. But what we're caring about for this is that if anybody begins overlapping us, right, and if you walk inside of here, it'll generate an overlap event. That's what it does. That's what it's there for. And if you go to the collision tab, you can see all the different options for collisions and overlapping. So a collision is when you run into something and you can't go through them. That will generate a hit event if you have it set to generate hit events. And then overlap events are when you can walk inside of something. So those are kind of similar concepts, but at the same time still kind of different. So if we come over here, when they begin overlapping us, we're just going to print hello. And if we hit play now, hello, hello, hello. And here's a little secret. If you can get it to say hello, you can get it to do anything, right? The hardest thing is actually that first step, like, is it going to generate the overlap event? Because Unreal Engine, for all its benefits, all of its nice bits, one of the most annoying things about it is that when something fails, it'll usually fail silently, and usually have no idea why it's not working, right? So if you try doing this blueprint here and you walk forward and nothing, That's why we just have one node attached to it, print string, right? So when something begins overlapping us, print hello. Okay. Now that I know that it's working, I can take it out. So this is a really good way of doing development. Just, you know, I attach a hello world here. Okay, play the game. Okay, it printed hello world once. I attach print string to this. It printed every frame. And then with this one, it printed when I got close to it. Okay. So what I'd like to do is, I don't know, maybe have the snowman say something to the player. That could be fun. Scratch website, yeah, it is a visual programming system. Scratch is similar in that regard, but Scratch, if you look at the way they do loops and things like that, it's quite different. Like you click the code inside of the code like that. Whereas over here, you know, you might have like a for each loop like this, and so it takes an array as an input, and then for each element of the array, it does something like that string or something like that, right? So if you had a bunch of things, then for each thing in that array, it would print hello. This is different from Scratch, right? Scratch nests everything inside of each other. This one, the flow of control is just white pin to white pin to white pin, right? And it just runs down the line until it gets to the end. Okay, so go away, human. All right, yeah, let's do that. Let's see if I can get the voice recorder running here. Go away, human! That work? I wonder if it's because it's recording currently. Did it crash? No. 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 Okay, no, the mic's working. It just had a super long delay on it for some reason. Okay. Go away, human! Go away, human! Alright, good enough. Open file location. So I just, to record that, I went to the start menu and typed in a voice recorder. Right? This is a built-in program that you can use to record off your webcam or whatever. And let's see here. Ooh, it's an M4A format. Let's see if that can import into Unreal. Unreal can do wave and FLAC. Don't know if it can do M4A. Let's try that. So if you want to import something into your world, you just drag it in like this. And it will not play it. Okay. So that's annoying. We're going to need to do a converter. Just adding more steps, M4A to wave converter. Drag and drop files. Huh? So I'm going to convert this. Convert to wave. Uploaded. Converted. Exported. Download. Save it to the desktop. Okay. So then over here, I'm going to come into the desktop. And this is how you import things into Unreal. You just go to the File Explorer and you can just drag a file in like that. That's all you do. If you want to be a little more, I don't know, different, you can always click on the giant green button here for Add and Import, and you can just add a import into Game Bill, and then you can go up to the desktop and choose that recording we just made, and it will appear here. There you go. Okay, if I double click on it, it'll pull up the wave editor here. And none of this is particularly interesting, I guess. You can override the volume and the pitch if you want. You can make it loop so it plays over and over again. Quality. Streaming. Yeah, none of that's particularly interesting. Okay, so what I'm going to do is right click on this and choose Make Cue right here. Create a cue out of it. And so there's another system which I'm briefly going to show you called Go Away Cue. And so this is the sort of better way of working with wave files and things like that. So if I hit play, right? And so this offers a lot more options. And you can do things like add in a modulator. And so if I wire it up this way, the modulator can be used to randomly change the pitch up and down and play quieter and louder. So it won't sound exactly the same every time. And there's a lot you can do with the audio cues. I am going to ignore them for now because we're already talking about blueprints. So what I want is that when somebody begins overlapping us, I want to just play a sound. Okay? So I'm going to drag off from that white pen, choose play sound at location. And I'm going to choose a sound that I'm going to play here. And I'm going to choose Go Away. Okay. The location is the world origin, which who knows where that is. So what you need to do is get your location. So we can right click. If you right click on the blueprints area, it'll open up a new search option. I'm just going to choose Get World Location. And I can choose which part of my body to get the origin from. That's where the sound's going to play. So it sounds like the nose is probably the right place for the sound to come out of, right? Because it's kind of where the mouth is. And so Get World Location takes your nose as input, or I pick the nose as input, and it's going to output the location in the world where the nose is. And that I just hook up like this. You notice how they're color coded? We got orange to orange. You got blue to blue, and I think green to green, and things like that. That's called the type of the variable. And so orange is a vector 3D, an X, Y, and Z location. And so if we don't provide it with anything, it'll just play at the world origin, which would confuse the hell out of people there. If it was a multiplayer game. Or might just confuse you, because Go Away Humans coming from over there instead of from over here. But I am not going to play it from the world origin. I am going to hook up this here. And now it's going, every time somebody overlaps the Frosty, it's going to play Go Away Human at the location of the nose. So, space it out a little bit. I like getting everything tidy. There we go. So if we do this, there you go. Come back in. Okay. And the reason why it works from behind is because I set up a sphere collision, right? So all that happens is that when somebody walks into that sphere collision, then it plays Go Away. Okay? So let's open this up one more time. And yep, the old classic music conversion. You can also send files into the project folders. Yeah, if you drag things into the project folders, that'll work. You can also, let's see, right click here and choose import up here. There's a lot of ways of doing things in Unreal Engine. So giant green buttons is probably the most obvious. You can't hear my sound? Yeah. I can fix that. Share screen, change windows. I'll share this one. Okay. Can you hear it now? And the pitch is changing every time because I made the sound cue here. Sound cue, I attach a modulator to it so that it would go up and down in pitch every time. Okay, so this is a example of a very simple blueprint, right? So every time somebody starts overlapping us, play a sound. Now we can do something else. We could damage the player, you know. We can open a door. There's a lot of things you can do with these things. This is one of your basic tools for making a video game. One of your basic tools is overlapping. When you overlap something, do something. That's just one of your basic, most primitive, most powerful tools for making interactive game environments. You know, you walk up to a lamp, the lamp turns on. Cool. Like for example, I can make it so that when you leave the area of the snowman vanishes. Okay. If you hit delete, by the way, you can delete things like that. They can come back. Event tick. Comes right on back if you want them. So a lot of times I'll just clean these things up so they're not in the way. So if there's an event to begin overlapping, what do you think the event to end overlapping is called? So if you just had to guess off the top of your head, having never done this before, what do you think the event to end overlap is going to be called? End overlap? Let's give it a shot. So when you're doing blueprint editing, if you right click, it pulls up this really smart search thing. And so like if you want to add an if statement, you can just like type in if, and it will highlight branch, which doesn't have, it's not an if statement. It's an if statement, but it's not called it. And so it's smart. It knows that if you type in if, you want to branch, do one thing or another thing. So it's not always the best, but it's pretty good most of the time. So yeah, let's search for event end overlap. And here we have event actor end overlap. Okay. Right? You see how it's symmetrical with this one? Event actor begin overlap, event actor end overlap. Okay. So let's make it so that when the person walks away, the snowman just hides himself. Okay. Let's see if that works. Video isn't showing. Video isn't showing. What about now? It's streaming? No? I'll try restarting. Stream is still running. Is it not uploading? Is it loading? It's not loading, huh? Let's see if we can figure this out. I'll pause the recording. Okay, let's start recording again. I don't know why the stream went down. So what I'm going to do is when the actor ends overlap, I am going to, I dragged, you can drag parts of the, of your blueprint into the world. This is actually one of the reasons why it's up here. You know, you got your viewport here that shows you what it looks like, but you can actually drag parts of the thing in here. Like if I wanted to just make the nose vanish, let's say, I could drag the nose down here, like that. And then I could drag that into a node called set visibility. And set visibility can be used to hide and show things. So for example, you want to, I don't know, a wall to vanish, you know, and demons to come out or something. You can do that this way. So the visibility of the nose is going to be set to be false. You can set it to be true to show it, false to hide it. And propagate to children means any of its children, in this case the eyes, are going to vanish as well. And that's a little creepy, so I'm not going to propagate it to children. I just want the nose to vanish. And let's see how that looks here. So, you know, rather than minimizing this thing constantly, one thing you can do is you can take the tab and snap it up to here, and then you just kind of click over this way. It's a little bit easier. All right, hit play. Go away, human. And you walk away, and then the nose vanishes. You see that? And if we instead set it to propagate to children, because the eyes are children of the nose, you can tell that because you see how there's like a little drop-down option here. They're the children of the nose, so everywhere the nose moves, watch. If I move the nose, the eyes move too. You see that? Because they're children of it. So any transformation that is done to the parent gets done to the children automatically. This is really useful when you have something like an arm. If you move the upper arm, the lower arm comes along for the ride. If you move the lower arm, the hand comes along for the ride. If you move the hand, the fingers come along for the ride. If you move the upper finger, the lower finger comes along for the ride. And so you don't have to like move everything separately. You just move your arm and then everything else just kind of comes along. In this case, it doesn't exactly make sense for the eyes to be the children of the nose, but this one does down here. So if I move the bottom ball of the snowman, the upper balls come with. Okay. Whereas if I click on this one, right? Because sphere 2 is a child of sphere 1, and sphere 1 is a child of sphere 2. But the nose, for some reason, is a sibling. It's not parented to it. So really, we should attach it to sphere 2 like that. And I1 should be attached to sphere 2, and I2 should be attached to sphere 2. Okay. Actually, no, wait. I was going to show propagate to children. So let's leave that on for a second. So propagate to children. Okay. So let's just show what that looks like. So come in here, and then all three of them vanish. So yeah, in reality, I1 and I2 should not be children of the nose. It doesn't really make sense. Is visibility just to alter what you see? It does not. That's a good question. Let's try setting the visibility of the sphere to be 0. Nope. Still there, just doesn't draw it. Okay. Okay. So if you wanted to delete it, that's a different thing. We can do that, of course. So when we end overlap, rather than setting visibility, if you ever want to cut a wire, by the way, you can right-click on the pin and choose Break All Pin Links. That's one way you can do it. Another way is to Control-click on the wire and then click away. That's another way of snipping a wire. So if I just kind of move this out of the way over here, I can just say Destroy Actor like that. This is a very permanent node. So make sure that you know what you're doing when you destroy something. A lot of times it's better to just hide it, because if somebody has like you in a variable or something, then they could be referring to an actor that's been destroyed. But you know, it's probably a good tool to have in your toolbox. So we come up here, and then bloop, it's gone, and now there's nothing there. Okay. Or you can, you know, if you wanted to do like some sort of vanishing door, you can make it so that you walk up and then it destroys itself or something, you know. Let's walk up and do a delay of, no, yeah, actually let's do this. Go away human, and then we're gonna delay. We're gonna delay for, that's a new thing too. Everything's new. Everything's new and bright and shiny for you guys. We're gonna delay for 2 seconds, and then we're gonna destroy the actor. And by the way, you can do this. This will actually work. I don't think this wire could happen now because we're, well, I guess if we end the overlap, yeah, it's doable. Okay, so here we go. And then there's a 2-second delay, and then it. Okay, so if you want to make a door that just vanishes, doesn't even move, it just vanishes, you can use destroy actor for that purpose. Okay. So we can also, rather than destroying an actor, we could spawn an actor. That could be fun. So rather than destroying an actor, we can spawn an actor from class. And so we walk up, and 2 seconds later, we are going to spawn a new yeller. And what I did was I right-clicked on the spawn transform and chose split. And that'll allow me to choose the position, rotation, and scale, these 3 things we always work with separately. So I'm going to spawn a new snowman 3 meters behind the current one. I don't know. That sounds fun. 4 meters behind the current one. I don't know. Okay, so how do you do that? How do you get the direction something's looking? Well, I'm not going to ask a rhetorical question because I know the answer. So there's something called the get forward vector. Get forward vector gets you the direction you're looking, and that's actually not exactly what we want. Get forward for, let's say, the actor, us, and that's going to give us a vector pointing in the direction that we're looking. It is in fact this little it's an arrow this way in the direction we're looking. Okay, a unit vector. It's 1 centimeter long, pointing in the direction we're looking. So if we want to make a snowman appear 4 meters behind us, then we have to multiply this by -1, right? So we have to multiply this by -1. That's the behind. There's no behind vector. There's a forward vector, a right vector, and an up vector that corresponds to the x, y, and z directions. Hit times, so I'm going to multiply a vector times a float. I'm going to times this by -1. Congratulations, we now have a vector pointing behind us. And if this is 1 centimeter long, what do I need to multiply it by to get to 4 meters? So it's a vector pointing behind the snowman, 1 centimeter in length. What do I have to multiply 1 centimeter by to get 4 meters? Anyone SI trained? Anyone know the metric system? 19 to learn the metric system, fair enough. All right, so we're going to multiply this by 400. And if it doesn't work, I'm going to blame you on that. Kidding. All right, so we're going to, yeah, so this is a pretty straightforward way. We get the direction we're looking, which is always a unit vector, 1 centimeter. We multiply by -1 to get behind us, and we could probably combine these two into one thing, right? Like we could multiply it just by -400. All right. Like that. So that'll be 400 units behind us. And that's the location we're going to spawn another yeller. The rotation we could set, which we don't care. The scale, sure, let's make it a little bit bigger. Just to make it funny. 2, 2, and 2. Okay. Yeah, okay, let's try this. It's doubling every time, by the way, which is why it starts lagging and crashing. Every 2 seconds, it's doubling the number of snowmen out there. So that was, it says the forward vector is in the y direction. That's interesting. Okay. So let's come back in here. So let's rotate you 90 degrees to the left. Let's try that. There we go. Oh, they're doubling each time. Yeah, so let's spawn a new actor and then delete the current one. We're going to spawn a new one behind us, and we're going to destroy the current one. That way we don't get exponential growth. Yeah. Destroy actor self. Okay. I don't know what's going on. It's kind of crazy. Anyhow, that'll give you an idea of how that kind of stuff works. Okay. 2 seconds, it spawns one. Let's try to adjust. Let's try that. See, figure out what's going on. Yeah, it's a weird interaction when you're destroying things and making things in this because it's recursive, right? We have a yeller making a yeller, so it's a bit weird. Let's just yeah, let's just play a sound. That's fine. Okay, so we got half an hour left. What other things are important? So we've learned how to do things on every tick. So every tick we can do something. We can do things when the world begins. Here we're doing things when they start overlapping. The collision, sphere collision. And we can do things when they stop overlapping the sphere collision. What things we can do? We can print a string to the screen. We can play a sound. We can destroy an actor, spawn a new actor. We can do an emitter. That's kind of cool. So spawn emitter at location is going to do a explosion. Cool. So we're going to play an explosion. By default, it's going to be at the world root, and then we'll just destroy ourselves. So we're an exploding destroy actor. So we're going to just have a exploding snowman or snow woman, whatever. Okay, but the explosion is going to come out of the world origin, which is going to look weird. So let's do this. Let's rotate this. So you see how we didn't see an explosion at all? We don't know where the world origin is, right? We're at negative 500, 600 right now. Who knows where the explosion is? You know what I mean? So you never really want to use the world origin for anything. It'll just confuse you. So we want to get the location of us. So we're going to get the world location, and we can pick a component. I'll just pick the nose. I guess that'll be a funny thing to have explode. So I'm just going to move these guys around over here. So we're going to get the location of the nose. And yeah, okay. You see that? So the explosion actually comes out of the nose, right? Okay. Kind of cool. Possibilities are nearly endless. Yeah, they really are. They really are. And I'm throwing kind of like a lot of things at you right now. We've still got half an hour more. So blueprints are pretty cool. How about we make the human able to attack? That sounds cool, right? How does that sound? So far we've got overlap. We can do touch also. So if let's just show that one real fast. Come into Yeller again. So rather than beginning overlap, which is when they walk within this sphere collision, we can make it happen when you touch the snowman or snowwoman. So let's just cut this off here and choose event on hit. And so when somebody hits us, we actually can get lots of information about who hit us. And one thing we're going to do is we're going to, yeah, whatever. Let's just hook it up and see what happens. And if it's buggy, we'll fix it. Okay. So if anything hits us, then we're going to play a sound, go away, explode, destroy ourselves. Okay. And save, and let's see if that works. So you see the overlap isn't triggering now, but if I touch it, it explodes. Okay. Do you guys understand? So different events. This is called event-driven programming, where events start your code off. It's not main, it's not running in main. Instead, what happens is that this code just doesn't run until something happens. So if it gets touched, if it gets overlapped, if it gets placed into the world, then it runs code. Okay. So what kind of events are there? When put into the world, every frame, when overlapped, when touched, when ending overlap. There's a lot of different triggers that you can use to do code. And what can you do with your code? You can play sounds, you can play special effects, you can do damage to somebody. Really, kind of anything you can think of. And this is how you kind of make a video game, right? So in this case, we're playing a sound, spawning an explosion, and then destroying it, which, it's kind of amusing. Exploding snowmen, all that stuff. And if you care about who touches you, you can get all that information about the collision. What point was hit? Like there's a lot of information that you can grab about this collision that just took place. Pretty common one is to do this cast to. So casting is when you convert one type of variable to another type of variable. And it's actually used in Unreal Engine for more than just converting the type of variable. It's used as sort of like an if statement. Like if we were hit by the third person character, which is the name of the actually that isn't our name, is it? What is our name? Walk, run, main character. Main character, yeah. Okay, so we drag out from here and choose cast to main character. So what this is going to do, it's going to convert the person that ran into us into a main character. Or it'll try to. Like, suppose like a ball hits it or something, and we don't want it to explode if a ball hits it. We only want it to explode if the player runs into it. So we convert this person that hit us into a main character. And the reason why we do this, again, it's like an if statement. It's like saying if the person who ran into us is the main character, then do this stuff here. If it was not, then do something else, potentially. You don't have to. And then, so if that casting was successful, then it plays the sound, it spawns the emitter, destroys the actor, and still works. Okay. So weapons. Let's make a weapon on the player. So we'll set Yeller aside for now. maybe. No, let's add a new event. Okay, so we've gone over every frame, on overlap, on touch, end overlap, begin play. We're gonna make our own event now though, and so you can just like add event, add custom event right here, and we're gonna call this one Death Strikes. I don't know. It's kind of a cool name. All right, and so you can actually wire up. Watch this. You can actually wire up two different events of the same thing. So either if we get event hit, or if somebody calls the Death Strikes event on us, which is what we're going to do from the player side of things, then it will. No, not casting. We don't have that. We'll just come over here. Okay. So if the player's attack hits us, it's going to call a Death Strike event, and that event is going to flow into here. It'll play the sound, spawn an emitter, destroy the actor. So there's two different ways of coming in. We can either come in by touching it here, or by the player calling Death Strikes on the yeller. Okay, so let's come over into the main character, which is for you guys called the third person blueprint. For y'all, it'll be in the third person BP folder instead of blueprints. I think I deleted mine, but there's a blueprint there called third person BP, and that's where you can edit all this kind of stuff. I just made my own. That's why it doesn't have like jump animations and things like that. Okay, so we want to have clicking attack, right? And the animation side of things is a little bit outside of our scope today. So how about we just like shoot a laser beam or something? Kind of like what I had in my game. That's a bit easier. And so what we want is that when the user clicks, there's an event for that. And normally there would be something like event action or something like that. Nothing. There actually is not an event for clicking. We have to make one. Okay. And now we could do like event mouse, left mouse button. That we could actually just do it here, which will probably be all right. Like if we can do print string, we can print mouse down. Zoom in so you can see what I'm doing. And when we let go of the mouse, print string mouse up. And I'm just doing this to verify that things are working, because again, the worst thing in Unreal Engine is just nothing happens. So we do this, click, mouse down, mouse up, mouse down, mouse up, mouse down, mouse up, mouse down, mouse up. Okay, so that works fine. However, I don't want to do this. I'm actually going to show you guys how to bind input. Okay, so I'm going to delete this. And if you want to create your own control scheme and things like that, like if you have a controller and you want to support both mouse and keyboard and gamepad or whatever, let me show you how to do that. You come up here into Edit, Project Settings. You go to Edit, Project Settings, and then move the window over to the other screen. And then there is a tab down here called Input. So Input is all of the different events that are set up essentially for your game. And there's a lot of stupid stuff in here for VR that you can just safely delete. I'm going to keep gamepad support just in case, but all this VR stuff I'm going to delete. Okay. So, reset VR, we do not need. Jump is spacebar or a bunch of other stuff we don't need. I'm deleting them not because they're bad, but just because it's going to take up screen real estate. So you can see that there's an event for spacebar here. And if we were to come into the main character, you'll see that there is an event somewhere within here. Nope, it's not bound currently. So what I can do is say event, what are they called? Event jump. Yeah. So the project settings has a event called jump, and so when I hit space, it'll call jump. And so this I can actually do the same thing as before, print string, and we're going to say start jump. And released string jump released. Okay. And so what's going on here? In project settings, you can create events that'll happen, and you can bind keys and VR controllers and things like that to it. I'm going to show you how to do left click in just 1 second. But basically, because you have this thing here, it's in, again, project settings, input, and bindings. Because we've created an event here called jump, then when we're in our blueprint, there is a input action jump set up. And so when we press the space key, it's going to say jump. And then when we let go of the space key, it's going to say jump released. So if we do this, jump, jump release, jump, jump release. Note, nothing is happening other than that. The blueprint itself is simply printing a string. It doesn't actually do a jump. So you just have it called jump, I guess. And let go, stop jumping. I don't know if I have the character movement set up for this, because I sort of created a blank. Oh, there we go. All right. Jump. So we've just added jumping to the game. That's cool. Oh, yeah. Go away, human. Okay, so yeah, that's still happening. Okay, so let's make it so that when you click, it shoots a laser beam out, and if it hits Old Yeller, the snowman, then it destroys Old Yeller. Okay, so to do this, we have to go into our project settings, input, engine input, and we're going to add a new action mapping, and this one is going to be called attack. Okay, and the binding for it is just going to be mouse left click, left mouse button, and we can add like maybe a gamepad, face button left or something. That might work. Okay. And so if we save that, so what I did was I created a new action mapping, and I created a new event called attack. And then I clicked plus a couple times and chose the key binds. I could bind a key to this as well. I could bind like the K key. Here, let's see that. K key. That's a little shortcut. You can click on that and then tap a key, and then it'll bind it, so you don't have to hunt around for it. So, and you can make it if it's Shift K. Let's do that. Shift K will make attack as well. I don't know why, but it'll demonstrate to you guys how this thing works. So you can have multiple things bound to the same thing. That's why it's better than grabbing like the K key or whatever, right? Because then you'd have to have events for each one of the different sources of input. Okay, so, and you can also rebind your stuff, stuff like that as well. Whereas if you have a blueprint for left mouse click, that can't be rebound, you know what I mean? Okay, so input action attack here. And so print string as always. Just print hello. Play. So if I run around and I hit Shift K, hello, 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 hello. If I left mouse click, hello, hello, hello. So we have got our stuff together. We are now activating, so I can pull that out. And what I want to do is shoot a laser from my face, and if I hit an Old Yeller, then take Old Yeller out behind the barn and shoot it. So let's do something called a trace line, or a line trace is called in Unreal Engine. So this is this thing here is, pay attention. I know we're towards the end of class, but this is actually really, really important. This is probably the most important thing I've talked about all day. And this is how you interact with things in the world that you're not touching, right? I've talked about 2 ways of interacting so far, overlap and hit. This is how you actually make a weapon work. Like if you have a hit scan weapon where you shoot and an invisible line comes out, and if it hits something, then they die. This is how you do it, okay? And there's many different variants of line trace, or trace line as it's called sometimes. But this is the basic one here. And you have to pick a starting location and an ending location. The starting location is going to be our gun. In this case, I think we're a knight or something, so it'll be, I don't know, camera. Where do we want it to come out of? Arrow component. I guess that'll work. We'll have it come out of the arrow component. Okay. So the starting point is going to be the location of the arrow component. Can I do that? Nah, okay. Let's just do the mesh then. So we're going to grab the mesh. That's the player. Yeah, I guess that'll work. And we're going to drag out from there and say get world location. And so this trace line is going to start at our body. And the place where it's going to end, it's going to be pretty similar to what we had before. We want to get the forward vector out of this guy. So get forward vector. And this is a unit vector. It's a centimeter long, pointing in the direction the body's looking. And so we're going to take this vector pointing 1 centimeter in the direction we're looking, and we're going to scale it by a factor of, I don't know, how long do you want the range to be? What do you guys think? How long do you think the range on this laser weapon should be? 25 units. 25 meters or 25 centimeters? It's a pretty big difference. 25 centimeters. Okay, well, we'll scale it by 25 centimeters. That's okay. And so we're going to take that, and so that's going to be a vector pointing 25 centimeters in the direction we're looking, and we're going to add it to our location to get the final location. Vector plus vector. And that's going to be the ending location. So you need to do a little bit of linear algebra. We're going to have a lecture on this, how all this stuff works, so don't worry too much about it. But basically, hopefully it makes sense. It's going to start at our location, and it's going to go forward 25 units. Think of it that way. So it's starting at our location, start location. The ending location is our starting location plus 25 units in the direction we're looking. Okay. And then we're going to turn on draw debug type for a duration of 2 seconds. So it's going to draw a laser on the screen. Nothing. There we go. I think it's coming out of the world origin. Let's see. What do we do wrong here? All right. No, not you. Main character. Line trace. World location. Forward vector. Times. Now let's increase the range on this to like 10,000. See if that makes a difference. 25 might be so small we actually can't even see it. All right. Yeah, there's something going on there. I think our vector math is wrong here. I can see the lasers appearing down there. Let's see if I can figure it out. Haven't had much sleep today. Main character, mesh. Do we really want mesh? Get the world location. Forward vector. Let's start. Let's see. Wrong with that. get our location, added to the forward vector times the range, which I made a variable properly. Adding them together, that's the start, that's the end. Yeah, it's the same pattern, I think. World location, range. Oh. Where was I? Zombie blueprint. Yeah. Let's not use the mesh. Get actor location. So rather than the scene component, let's do this. And our location is the start, and then our forward vector times 10,000 plus our location is the end. I'm going to make it a permanent line just so I can see it. It's going to ignore ourself. Okay, that looks pretty good. No, not compiled. Get forward vector of ourself, doesn't like it. Let's try the camera. Might be nice. We'll shoot a laser in the direction we're looking, at least. Okay. All right, hit play. There we go. Okay. And what I want is if I hit the old yeller with this laser beam, then it's kind of like entrapment with Catherine Zeta-Jones. To dodge the lasers. So what I want is that if it hits the old yeller here, then it calls that function called death strike or whatever. So main character. Okay, so line trace by channel is very, very important. That is how you can like throw a line through the world and it tells you the first thing you hit. Okay, and so this thing here, you can actually right click on it and choose split, and then that actually gives you all the different bits of information, like what did it hit, what bone did it hit, what is the angle of impact, there's a huge, what material did you hit, there's a huge amount of data that you get out of this thing. Basically all I'm going to care about is the hit actor, the person we hit, and I'm going to start off actually just with print string as always. Print string, do my debug, and I'm going to drag from the actor to the string, and what you'll see is that it actually drops in between get display name, which is the name of the object in the world editor. And so if I do this, I could click and it tells me floor, cube mesh 4, cube mesh 3. So it's kind of telling me the things that I'm hitting, right? Floor, yeller, linear stair, static mesh, sphere, yeller. Okay, so cool. One of those things was yeller. So we're going to drag from here and we're going to say if we hit yeller, and we're going to do that again with cast to yeller. That is just like almost saying, you know, if we hit yeller. So we hook that up here. Then we are going to do something. If we did not hit yeller, then do absolutely nothing. So we're going to call death strikes on it here because we created that event a while back called death strikes. It will call that event on yeller, which is this one, and then it will play the sound go away human. Actually, nah, let's not play the sound. That's a little weird. If we shoot it, we're just going to spawn the emitter and destroy it. Okay. Save. Done. There we go. So we successfully death striked old yeller. So if I miss, nothing happens. But if I aim, boom. One shot, one kill. Okay. All right, so pretty good. There's a laser weapon. Let's not make it persistent anymore. Let's just make the laser appear for like 1 second or something. Compile, save old Yeller. Save the map. Boom. Now these things are actually debug drawings, like they just are there so you can see that your linear algebra is working right. And you can kind of see what it's impacting as well. If you want to do an actual laser like I had, then that's a lecture for a different time. But that's good enough for today. So we went over a lot of stuff today. This was a really important lecture today. So unfortunately, like Hazelton and some other people aren't here. I don't know. Not gonna tell you. But yeah, what are all the different things we learned? Well, first, to summarize, we learned you can build a model inside of Blueprints, and then they all come together, and you can parent them so that if something happens to the parent, it happens to the child as well, but not vice versa. Then there's something called an event graph, and the event graph is where we do our programming, and there's a bunch of different events that can happen, and we can tie code to all of those different events. We can tie a hit function so that if somebody walks into us, it prints out "Go away, human," and it explodes. We can tie an event that we made ourselves called death strikes, that if that gets called by our other code, it explodes us. We've got code for if somebody begins overlapping our sphere collision here. We've got code if somebody touches us. We've got code if somebody stops overlapping us. We had code for like every frame. There's a huge amount of things you can do that start your code running. And then once your code starts running, what can you do? You can play a sound. You can spawn an emitter for a particle effect. You can destroy yourself. You can spawn another actor. You can set the visibility to be true or false. There is just a huge amount of things you can do. You can order the actor to move towards the location or something like that. There's just a lot of stuff you can do. And this is just kind of a very short, concise overview of some of that stuff. And then on the main character side, we made our own event called Input Action Attack, which was reachable through Edit, Project Settings, Input. And so we created a new event called Attack, and we bound 3 different things to it: left mouse, the left button on the gamepad, and Shift K for some reason. So if we were to run this, I forgot about Shift K. Do we miss? Shift K, Shift K, Shift K. There we go. So Shift K does work as intended. Take off the shift, it's a little awkward. So you can come into the input thing, create new events, and then you can bind keyboard and mouse events and gamepad and a bunch of other events as well to it. And then inside of your blueprint, you can use that event that you created over there and say when the event begins, when the event ends, and I'm not doing anything when it ends, but when it begins, I'm doing a line trace, and line trace is the most important node that I showed today, because that draws an invisible line, usually invisible, here it's visible. It draws an invisible line through the world and tells you the first thing you hit. And so this is used for any sort of hit scan weapon. If an AI wants to see if it can see a player, it will shoot a trace line out, and if it gets blocked, okay, I can't see the player. This is like one of your fundamental building blocks of game development. It's the trace line. Okay. And it gives you tons and tons of information, none of which I use except for who did I hit. And so casting is like saying, if I hit Yeller, then call this event on them. If I hit anyone else, do nothing. Okay. And then finally, of course, we learned print string, which you might see I use all over the place just to make sure stuff is happening. Because if you don't, and then it doesn't work, then you're like, where is the point where it didn't work? And several times in my development process, I got stuck. Once because I had an alpha value of 0. Another time because when I made the laser zombies invisible, the animation wasn't animating anymore because the game engine knew it wasn't visible, so it wasn't bothering animating an invisible person. But my particle effect system needed those animations to be animating because it coats the invisible surface of the mesh in this series of points. And so figuring out how to get that working was an hour of my life, you know. So, yeah. That was today. Good lecture today. Hope you guys all learned a lot. Your homework assignment will be to turn your snowman into a blueprint and do something with it. So I'll give you mine here, but you can do anything you like. I'll just toss this up on Discord. Kind of some dead code here, like this code doesn't do anything, right? This code doesn't do anything, that code doesn't do anything. But, you know, the pieces of the puzzle are there. So go ahead and make some sort of interactive snowman. Okay? And that'll be due on Tuesday. All right. That's it, everyone. Thank you very much. And I will see you on Tuesday. Or, yeah, Labor Day weekend. Yeah, Tuesday. Okay. Cool. All right. See you guys.